what you need are for this. Actually, lots of things that I'm going to use for. Okay, so if you are given 3 points, can I go here, please? If you're given 3 points, you can make a plane from that. You can also make it from a point. Oops, and a line, I should say. C is going to be 2 intersecting lines. And I put in bracket, that's a point and 2 direction vectors. And 2 parallel and non-coincident lines. Okay, our main one that we'll be using is letter C, okay, because from A, B, and D, we'll turn it into a point and 2 direction vectors. That's sort of the standard one we're going to be using here. Okay, we're going to say here then, the vector equation of a plane is going to be pi SA What's that, sir?
Is Sn a vector?
No, just A is a vector. S is just a
Scalar number.
yeah, just a number there. So. Okay, can anyone guess, and we'll do it in English here and we'll deal with details in a sec. How would you deal with a parametric equation of a plane? What would you do then? What would the parametric equation of a plane be? Well, okay, think of what you did. Let's pretend this isn't here. You guys can do that, no problem, right? Yeah, go ahead. Right on. Very good. So the parametric equation of the plane is pi. We're going to say x is equal to oh shoot. So basically, it's just the coordinates. That's all basically parametric is, right? It's just taking the coordinates. And it's sort of hard to sort of understand what's going on here. We'll do a few examples and just say, yeah, no problem. But it's the idea you're taking the components, right, of your vector form. Okay. Are we ready? Take a sec, soak it in. This is tricky. Like, this is where you gotta really focus your Harry. This is like the 4th quarter, down by 1. You need the ball back. Will you get a steal? Yes or no? We'll find out. What do you mean, no? Don't shake your head. You might get the steal. How would you know that?
What?
All right, here we go. Example 1. Okay, this is something that is horribly fundamentally important. If you have to understand this example before you leave the classroom today. Okay, this is horribly fundamentally, tremendously, am I clear enough? Important, okay? Here we go. That's what we're doing right now. So I'm going to say find the vector and parametric equations of the plane formed by the points A, -1, 3, 8, B, -1, 1, 0, and C, 4, 1, 1. All right, we're going to do I'll give you a second here. I'm going to pause the video, give a little bit of a chance to caught up, because I need us to work on this as a class. I was telling this to all the parents last night, and actually I hit pause here before I talk. In order to do this, we're going to need a point and two direction vectors. Can someone be brave and from the front row, aim your out, because you raised your hand 25 times today, you'll be back next round. Tell me how to find a direction vector. How would you do it? Good, good. So my first direction, which I'm going to call A, I guess, is going to be AB. So as Joe was saying, it's just going to be B minus A. So it's going to be -1 minus -1, 1 minus 3, 0 minus 8, which equals, what is that, 0, -2, and -8. Of course, because I'm a minimalist, that makes me unhappy. That will work for a direction vector. Can someone give me, in the second row, give me an equivalent direction vector that will make Mr. Sadler happier? Michael, you're out. Somebody else here. How can I do a 0, -2, and -8? What's a nicer one than that? It's a direction vector. Sorry? Good. What's even better than 0 and 2 and 8? Go ahead. 0, 1, 4, okay? So I'm going to say vector A, which is my first direction vector, is 0, 1, 4. Now if you think, Mr. Sadler, why can you do that? Well, what you would do when you're dealing with S and all this stuff, if you multiply it by -2, you get the same value, right? So all it's going to do is it's going to make the number that you're multiplying it by change, right? The direction vector is not going to make a difference. Okay, can I get someone in the back row to give me a second direction vector? BC works. You could have chosen AC as well. Okay, any combination will work. So BC will work. So vector B is going to be BC. Okay, can someone else in the back row, other than Benny, give me how to find BC, please? C minus B. Okay, so it's going to be 4 minus -1, 1 minus 3, and 1 minus 8. Is that correct? Whoa, goodness. Yeah. Naturally. Okay, so that should be, vector B is going to be 5, 0, 1. And I'm happy with that. They're positive. It's as small as it can go, so life is good. Unless my fraction, which nobody does. Okay, so I have my two direction vectors. So what I need someone in the front row is to pick their favorite point and then use that point to make a plane. I got someone in the front row. C is your favorite point? Lovely. So if we use C as your favorite point, can you make a plane out of this then?
I equals 4, 1, 1.
Yeah.
Plus S 0, 1, 4.
Yeah.
Plus T 5, 0, 1.
Great. Now that's sort of magical when you think about it. Okay. Just by those two things, you can get this entire blackboard. You know what I mean? You can cover every single space on there, every single point on there, given that, which is sort of cool. I think so. I'm a math teacher, though. Okay, so I think that's cool. Okay. Good. Excellent. Now, does most people understand where that came from? Okay, because this is a fundamental thing for this unit. Like this is one of these lessons that isn't difficult, but is horribly important. Question, go.
We have 3 components. Can we go out of the blackboard as well?
Yes. And I just happen to use the blackboard because it's easier to visualize. But really, for your first point, it would be like 4, 1, and 1. That's your point. And then your first direction vector is 0, 1, 4. So, oh boy, 0, 1, 4. Like it'd be going up like this. The second one is 5, 0, 1, 5, 0, 1. So the plane, this one would sort of be like this. Okay, with how it would look, right? So we'll get to that. As I said, I'll bring the iPad to you on Monday. We'll spend 10 minutes and just sort of see how they look here. Okay. Okay, great. Can someone in the second row be brave now and make the parametric form of that vector? How long the ladies in the second row? None, three of you guys never ever raise your hand ever the entire year. So one of you three, please be brave and give me a parametric equation, please. Oh, nobody says not it. We're saying not it, not it, not it. Somebody, please. Okay, go. X equals. Yeah.
4.
Yeah.
S.
Okay. Now remember the variables need to go with them. Probably when I'd be writing this, Emily, I'd probably just get rid of the 0s and I'd just call it 4 plus 5t. Okay. Great. Can I get someone from the back row to give me the next y value, please?
1 plus S.
1 plus s. 1 plus s. Good. Okay. Can I get someone from the front row to give me the z, please? 1 plus 4s. Now again, I spaced it so it would line up there, right? But that's the idea. Are we okay on what just happened there? Because this is fundamentally important. We're good? Matt, if I were to give you this and tell you to do it and it's worth 10 marks, you'd be able to do that for me.
Make it 20.
This is like gambling. Oh my goodness. I'm not looking forward to when my son told us, so I'll give you 10 bucks to make the lawn, to cut the lawn, make it 20. I'm not looking forward to that when that day comes. Okay. What's next? Here we go. Example 2. Okay, determine the vector and parametric equations of the plane. Containing the point P 1, negative 5, 9, and the line L, which is R equals 1, 1, 1 plus S, negative 1, 1. I probably messed physics up there. Sorry. Unless we square brackets. Okay, so this question is a slightly bit more complicated, and I'll tell you why. You have been given 1 point to start with, and then you've been given some other line. Okay, and I want you to make a plane out of that. So there's 2 different ways to do this. Actually, probably one way to do this, okay? What do you need to make a plane? What do you need? 1.2 direction vectors. Good. So we have our point. No problem. Okay? I'm going to draw on this board here, and hopefully this will become clear to you. If I say this is there's my plane, this is my point, and there's my line, how would I get direction vectors from that? Go ahead. Yeah, good. Okay? So let's say I pick this point and this point, or any 2 points. All of a sudden, wow, look at that. There's one direction vector, and there's another direction vector. Okay, so you see the logic there that we did? No? Because the thing is, we said we needed a point and 2 direction vectors, right? So in order to get, the other way to look at it is you can use 3 points, right? So if we know this line is on the plane, if you put any 2 points on this line, it's also going to be on the plane. So using this first point and the second point, you make one direction vector. This point and this point, and then the second point line, and make a second direction vector. And you have your point and starter with the 2 direction vectors. not yet?
Mr. Sadler,
Yes.
wouldn't it be easier to use the line and then just make one more direction vector?
That will work as well too. That's another way to do it too. So the other way you could have done it too, right, is just choose one point. And then again, this is going to be, that would be your direction vector, so that'll work for either one.
So planes don't have to be square.
No, definitely not. Okay. Like a plane, like it's hard to get that thing out. I'll bring the iPads in on Monday, okay? But a plane, think of it like an infinitely big piece of paper, right? It can look like this, it can look like this, it can look, you know what I mean? Like it's infinitely big. So the point is, if you have a point, and a line will make a point. Okay. Let's try it. Here we go. So let's try this one here too. So there's two ways to go. So I like what Michael said is here. I'll use Michael's point for this one. So what we're going to use is a point and two direction vectors. That's what we're looking for here. Okay, so my point is going to be, okay, I was given that point as my point. My first direction vector, I'm going to call A, vector A, is going to be -1, 1, 0. Okay? And again, from what Michael said there, right, if it's going to be on the plane already, the direction vector on the line will still also be the direction vector on the plane. Right? Now, the thing is, I need a second.
That's not direction vector on the line. That's a point on the line.
No, this is 1, 1, 0.
Oh,
Yeah.
looking at
Yeah, so 1, 1, 0 is going to be, so -1, 1, 0 is going to be the direction vector on the. Now, how am I going to get someone other than Michael here? How am I going to get my second direction vector? Good. You do got to pick a point on the line. We have been, luckily for us, we've been given a point on the line. What is the point on the line that we're going to use? Yeah, Jeff?
1, 1, 1.
1, 1, 1. Okay. So we're going to make vector B is going to be 1 minus 1, 1 minus -5, and 1 minus 9. So where this came from, I used the points. So let's write it. So vector B is from 1, -5, 9. So I used point P and then the point off my line as well. So somewhat good. I sense silence. I don't know what that silence means. Don't say that it's not Friday yet. It's 2:30. It's Friday in 40 minutes. Okay, good? Okay, so vector B then should be 1 minus 1 should be 0, if I did my math right. 6 and 8, -8. Okay, of course I'm horribly unhappy with that as a direction vector. Can someone please make us equivalent one to that? 0, 3, -4, okay. Now this is still correct, mind you. This is still correct, but always it's like bringing it to lowest term. That's all we're doing here, okay? So this goes down to B equals 0, 3, -4. Okay. So far so good? Okay. I got someone who has not spoken today in front of the class. Be brave and give me the vector equation of my plane. Someone who's not spoken today in front of the class. Can be anybody. No? Nobody knew? Oh goodness. Tyler, can you be brave? Tyler, can you do it? There we go.
Yeah. Is it, wait, so pi equals?
Yeah.
1, -5, 9
Great.
plus s,
Yeah.
-1, 1, 0
Good. Keep going.
plus t,
Yeah.
0, 3, -4.
Great.
The T and the S switched.
You could do it either way, right? Like it doesn't really matter. They're just the two direction vectors, right? Those are just variables to go with it, like the S and the T. So
It doesn't matter, just look at it. Okay.
They just mean a number.
yeah, exactly. Okay, from that, thank you very much, Harry. Thank you for being brave in front of the class. Can I get someone from the second row other than Michael? to be brave, please, and give me the parametric form of this equation. Oh my goodness. Go ahead. Go. Yes. X equals. Pause, please.
One minus S.
One minus S. So all we're doing here, sorry, for those that are blank out, I apologize. I keep forgetting, I've taught this course 5 straight years now, okay, so this isn't easy, I understand, I'm sorry, okay, the first time through I get it, okay, sorry. So this is like, you're just using the X coordinates here, right? So one's this, it's the X coordinate of this, so minus S, and then there's 0 T's, okay? Your Y is gonna be -5, plus S, plus 3T, and your Z is going to be 9, yeah, and 9 minus 14. Okay. Major questions before I keep moving here. Please be brave. Because again, today's lesson is one of these fundamental things. Like this will be like the first step you need to do before you get to the real questions, okay? If that's what we're doing today. Okay? What's that? All right. I'm going to hit pause the video, I think, before we keep moving. Where's my sheet? Oh, thank you. Let's hit pause in the video, and as I hit pause in the video, you can breathe in and breathe out 21